Okay, friends, we are going to start a new topic called coordinate geometry. Now, coordinate geometry is the greatest revolution in the world of mathematics, and it was all started by a mathematician called Descartes. He was a mathematician as well as a philosopher, and he created this revolution called coordinate geometry. In fact, this kind of geometry is called Cartesian geometry. Why it is called Cartesian geometry? Because we want to memorize the name of Mr. Descartes. Okay. Now, what he did was fantastic. He brought two fundamental branches of mathematics together. On one hand, we had geometry. On the other hand, we had algebra, right? So what he did is he brought these two branches together so that geometrical problem can be converted into algebraic problem, and use algebra, solve them, and again the geometrical problems are solved. Or conversely, take an algebraic problem, convert it into geometric problem, solve it by using geometry, and go back to algebra. Now see, you can solve geometry. So in other words, two very powerful tools were brought together and they were made 1,000 times better than the original tools. Why? Because this coordinate geometry is central, is the basis of entire physics that we learn. Entire technology depends on what? The coordinate geometry, knowledge of coordinate geometry. And in the coordinate geometry, in a geometry, if you look at it, the fundamental unit of geometry is point, and fundamental unit of algebra is number, right? So every point will be associated with numbers, right? And this bridge between algebra and geometry starts with that, okay? So how this was done? How a point is associated with numbers? A very simple construction was done. Everybody must be now aware of it. So a line was drawn, straight line. Then two straight lines were drawn, which are perpendicular to each other. So this was called x-axis, and this is called y-axis. Now, this part, so every point was given two coordinates called x and y. Now, what is this x and y? X is nothing but the distance of this point from y-axis. So this is x. This is x, okay? And this is called distance of the point from x-axis, correct? So here, this distance was called y coordinate, right? Sometimes this x is called abscissa, correct? Abscissa, correct? And this is called ordinate, okay? So these are the two names. So 2 points, the point was associated with a pair of numbers, right? So this distance was y, this distance was x, and this pair of numbers now represented the point. So every point is represented by numbers, and every ordered pair of this type is representing a point. So this was a bridge between coordinate geometry and algebra. Now we can use algebra for solving geometrical problems. That is the idea. So before that, we have to understand the concept of locus. Now what is a locus? Locus is basically it's just a set of points, right? Satisfying certain geometrical condition. Now what does that mean? That means you have a set of points, but not any randomly select collection of points. It's a collection of points which are brought together because they have certain similar property, right? They enjoy one common property, and that common property defines the set. Because every set, there are two methods. Either you write the least of method or the rule method. So rule here is what in order to be a member of that set, one has to follow certain rule, right? That rule is always the geometrical condition. So for example, straight lines, right? Straight line is a collection of points. So it's a collection of points, right? Infinitely many points are there on this straight line. And this is a set of points, and it satisfies certain condition. Another set is, for example, circle. What is the geometrical condition that it satisfies? It is always equidistant from the same, from a fixed point. So this distance always remain. So it's a set of all points which are at a particular distance from this fixed point, correct? So that is the condition, right? So every locus has got certain condition, and if you want that point to be member of that collection, then the coordinate of that point has to satisfy a certain condition. Now this geometrical condition can be converted into algebraic equation, correct? So that algebraic equation is called equation of locus. Okay. So I'll repeat again. Locus is a set of points satisfying certain geometrical condition, right? And the set of points will have set of coordinates. So in order to be a member or not be a member, those two coordinates will have to satisfy certain relationship among themselves, right? And therefore, that relationship will be called equation of locus. For example, if I put a condition that all the points whose x coordinate is equal to y coordinate, all the points whose x coordinate is equal to y coordinate, fine. So it will be what? It will be a straight line like this, because x and y are equal. So what will happen here is this distance is always equal to this distance, right? So therefore, x coordinate is equal to y coordinate. That means you will always get squares of this type, where the square, this is a square, this is a square. And if you take collection of all such points, they are on a straight line, correct? So therefore, this is going to be a straight line, correct? So therefore, some condition which is geometrical will be converted into an algebraic equation, which is nothing but a relation between x coordinate and y coordinate, right? That is called equation of the locus. Okay, fine. Now, our job is to study only one particular locus, that is called straight line. Now, before we consider straight line, I want you to understand one thing, that suppose there are 2 points in a coordinate plane. That means, of course, coordinate planes means Cartesian plane, as I explained earlier. This is x coordinate, x axis, and this one is a y axis, right? Now, if I take 2 points, one point here, say let us say P and let us say Q, right? Just imagine yourself walking along PQ. You are walking along PQ. You can clearly see that walking along PQ will be slightly difficult because it is walking upwards, So there is a inclination, there is a slope, right? And I want to find out slope. Slope means what? Slope means the ratio, because when you walk this distance, you are walking vertical, horizontal distance sum, and vertical. Suppose I come from P to here. That means I have actually walked certain horizontal distance and certain vertical distance. If I walk from here to here, I will walk some horizontal distance, some vertical distance. If I walk from here to here, I walk this much horizontal distance and this is a vertical distance. What you will notice is that all the triangles that I have drawn here are similar triangles because the angles are same. See, this angle is equal to this angle is equal to this angle, and this is 90 degrees, 90 degrees, 90 degrees, and these angles are also equal. That means all these triangles are similar triangles. And what is the property of similar triangles? The ratio of their sides are always equal. That means if I take this vertical side, divide it by horizontal, this will be same as this upon this. This will be same as this upon this. Therefore, this property called vertical distance divided by horizontal distance, that is called slope of the straight line. So this is called slope. So you have to understand the concept of slope. So what is slope? Suppose Q has coordinates x2, y2 and P has coordinates x1, y1, right? So that means this is y2, correct? And this is y1, okay? Now if I complete this, then this will be the difference here, and that difference will be y2 minus y1. And if I complete this, then this is x2, correct? And this is x1, right? So this distance is x1, this distance is x2. So therefore, this distance is going to be x2 minus x1. So vertical distance is y2 minus y1. This is vertical distance. Suppose I walk from P to Q, then I have walked this much horizontal and this much vertical distance. Now the ratio of these two will decide the inclination, right? So the slope is defined as slope of PQ. Slope of the line segment PQ is defined as y2 minus y1 divided by x2 minus x1, right? So the ratio of vertical distance divided by horizontal distance. That will define whether the slope is difficult to climb or not. The more steeper it becomes, the vertical distance is more and horizontal is less, then it will be difficult for you to walk. Now, if you walk straight like this, that means there is no horizontal distance at all and you have to just climb like this. It is impossible, right? So therefore, this is called slope. Now, this slope could be positive, could be negative, it could be 0, it could be infinity also. Now, how? See, if you are walking from P to Q like this. Now, in this case, you are climbing down. So, it will be easier for you to walk from P to Q. So, such a line will have negative slope, right? But a line like this, which is going up, will have positive slope, right? But if you are walking along the horizontal line like this, then the slope will be 0. Here the slope is 0. And if you are trying to walk along the vertical line, here it is impossible to walk. So here the slope will be infinity, right? So there are positive slopes. Generally, slope of PQ is generally denoted by a symbol M. So we normally reserve this letter M for indicating slope of the points, okay? Now, so once you have defined slope, let us find out some relation between slope and something called inclination, okay? So let us find out what is an inclination. So we are now talking about inclination of a line. Inclination of a line. What is inclination of a line? The angle that a line makes with positive direction of x-axis measured in anti-clockwise direction. Anti-clockwise direction is called inclination. Inclination of a line. What does that mean? Very simple. I'll show you. Here is y-axis, okay, and here is x-axis. This is a line. This is a straight line, okay. Now this straight line makes angle with what? X-axis. Positive direction of x-axis is this direction. So you start measuring the angle from this point, from this line, and anti-clockwise direction you will go up to the line. So this angle, which I denote by theta, is called inclination. So this is actually what? Inclination of the line. Inclination. Now remember one thing, I want you to understand one thing. Whenever two lines meet, the angle between them are actually 4. In fact, 8 angles can be described. So if I take one line like this and if I take another line like this, how many angles are there? See, 1, 2, 3, 4, 5, 6, 7, 8. Correct? So there are 8 possible angles. So we have to be very, very careful which angle we are talking about. So we are talking about angle between positive direction of x-axis and the line from positive direction of x-axis measured in anti-clockwise direction. That will be called the inclination. If you measure it in clockwise direction, it will be called, the inclination will be called negative, right? So this is the inclination. So inclination is what? This angle. Now, suppose I draw one line here like this. Suppose I draw another line here, right? So, you know the vertical distance and horizontal distance. If I take its ratio, then this angle, because of the parallel, so this line is parallel to this line, this crosses it. So this angle has to be theta only, right? And we have already seen that this ratio, this upon this ratio is called a slope. And that is nothing but tan theta, because this is a right angle triangle, this is opposite side, this is adjacent side. So the inclination and slope are connected to each other by a relation tan theta is equal to slope, right? because it is opposite side upon adjacent side, right? So that is called slope. So you have now understood the relation between slope and inclination. Okay, fine. Now, slope is a property not confined only to 2 points. What is a straight line? What is the defining property of a straight line? Property of a straight line can be defined like this, that it's a set of points. It's a set of points such that you pick up any 2 points. I pick up these two, or these two, or these two, or these two. Say, I'll take say P1, P2, P3, P4, P5, P6. Now I may take these 2 points and find out their slope. So that will be this. If I take these 2 points, I find out their slope. If I take these 2 points, find their slope. Or I take this point and this point, find their slope. Or I take this point and this point, right? So all these triangles are similar triangles and their ratios are equal. This is equal to this is upon this is equal to this upon this is equal to 6. So that gives me a definition of straight line. What is a straight line? Straight line is a collection of points, okay, such that, what condition does it satisfy? Such that if you select any 2 points, any pair of points from the collection, then their slope will be constant. It will never change. Doesn't matter which pair you have selected. You select P1, P2, you select P1, P4, you select P2, P5, you select P4, P6, whatever. But slope will always remain same. So that is the condition, that is a geometrical condition these points will satisfy. But this geometrical condition, can be converted into algebraic condition, because slope is nothing but the difference of coordinates of y2 and y1 and x2 and x1 ka ratio, correct? So this is what the equation of the definition of straight line is, right? You pick up any 2 points, slope will not change, correct? So now we know the locus. Locus is called straight line. What is a straight line? Collection of points. What condition they satisfy? You pick up any 2 points, the slope remains same, correct? So now, once we know locus, we should have an algebraic counterpart of that locus. That is called equation of that locus. What is equation of the locus? In order to be a point on the straight line, every point has coordinates x and y, and those x and y will satisfy a certain relation between them. That relation is called equation of straight line or equation of locus, correct? So now this is a straight line. In order to draw a unique straight line, you need at least 2 points on the straight line. So suppose I know this point and I know this point, then I will draw a straight line. Drawing what? The unique straight line can pass only through these 2 points, okay? So therefore, I should know at least a pair of points on the line, correct? So I should know the slope of the line, right? What is the slope? What is the inclination, right? So if I know slope of the line and 1 point on the line, so I know that slope of this line is given to me. Slope is given to be m, right? And I am given 1 point x1, y1 here. So this point I know. Now I will take any general point on this straight line, say x, y. Now this x and y has to satisfy certain condition in order to be a member of this collection. Now what is a collection? No matter what xy is, its slope with x1, y1, this point P, has to be always constant. And that constant we already know, it is m. So therefore, equation of a straight line, equation of a line, and this is every equation of a line has got certain forms. So this first form is called slope point form. Why it is called slope point form? Because given the slope is m and given the point x1, y1, so these 2 things are known to you, and from this you have to find out this equation. Therefore, so if we'll say let xy p x, y, right? let P, I'm sorry, let A, let us call it A, X comma Y be any point on the straight line, right? Then, and P X1, Y1 be a fixed point. It is given to us. It is not changeable, right? Fixed point. This xy is any point on the straight line. This x1, y1 is a fixed point, which we know already, right? Fixed point. Then, what is slope? Slope is known to be m, and that m has to be y minus y1 upon x minus x1, right? Y minus y1 upon x minus x1. That is the slope of this line, right? So, its equation is very simple. It's a set of all points x comma y such that y minus y1 upon x minus x1 has to be always equal to m. So this is the equation of straight line, and this is called slope point form. Only thing is, while writing this term is shifted on the other side. So y minus y1 is equal to m into x minus x1, right? This is the very, very important form of straight line, and it is called slope point form. See how easy it is, correct? For example, if I ask you, find the equation of a line with slope m is equal to 3 and passing through the point 1 comma 2, you will immediately solve this problem because you know x1, y1 and you know m. So what is x1, y1? 1 comma 2. So y minus 2 is equal to 3 into x minus 1, correct? So y minus 2 is equal to 3x minus 3. So this y is shifted on the other side. So 3x minus y and minus 3 on this side is equal to 1. This becomes the equation of the straight line. So if you want, suppose I ask you, find out whether 11, 10, whether this point lies on this line, you have to check that. Try to put it here. So what is the value of x? 11. So this will be 33. Minus 10, correct? 33 minus 10, is it 1? No. Therefore, this point is not a member. But if it satisfies, then it's a member, right? So therefore, remember one thing, this is the equation of straight line. And this is called the slope point form of equation of straight line, okay? Let us take the second form, that is called double point form of straight line. Double point form means what? Instead of giving you slope and point, you are given 2 points, right? So given 2 fixed points on the line. Let us say P, whose coordinates are x1, y1, and Q, whose coordinates are, let us say, x2, y2. Okay, these 2 points are there, and these are, so you can draw a unique line passing through these 2 points. This is point P, whose coordinates are x1, y1, and this is a point Q, whose coordinates are x2, y2, and you want the equation of this line, right, passing through these 2 points, right? So you are not given slope, but it is as good as giving you slope because y2 minus y1 upon x2 minus x1 is the slope of the line, correct? So, but these are 2 fixed points. I will take another general point here. Let us call it A, and that A will be general point xy, correct? So, we'll say like this, let A, x, comma, y be a general point on the line joining 2 fixed points, 2 points P x1 y1 and Q x2 y2, correct? So we already have one form. So we want to find out what is the m. So therefore, slope of the line. Slope of the line is nothing but m, and that m is nothing but fixed point y2 minus y1 upon x2 minus x1. Correct? This is the slope. You know 2 points, you need only 1 point in order to use slope point form. So, right? So, I will use this equation. So, y minus y1 is equal to m into x minus x1. Correct? So, which means y minus y1 is equal to y2 minus y1 divided by x2 minus x1 multiplied by x minus x1. Correct? So, therefore, I will write it in a slightly different manner. This y2 minus y1 I will shift on the other side. So, therefore, it becomes what? Y minus y1 divided by y2 minus y1 is equal to x minus x1 divided by x2 minus x1. This is also an equation of straight line and it is called double point form. It is called double point form. Why? Because in order to use this equation, we have to have a knowledge of 2 points on the line, right? So, for example, let us see. Find the equation of a line passing through the points 1, 2 and 5, 1. Correct? Suppose you are asked. So, these are the 2 points and you want to find the equation of this line, right? So, this formula will give you, this is x1, y1. For us, this is x1, y1 and this is what? x2, y2. Correct? Now, what is the equation? Formula is here, right? So, therefore, the equation of this straight line will be what? Y minus y1. What is y1? y1 is 2. Okay. Now, divided by y2 minus y1, that is 1 minus 2. This is equal to x minus x1. So, it is x minus x1. What is x1? 1 divided by x2, that is 5 minus x1. What is that? That is 1. Correct? So, therefore, the answer is y minus 2 upon minus 1 is equal to x minus 1 upon 4. Cross multiply. So, 4y minus 8 is equal to minus x plus 1. This minus goes here and it changes the sign. Bring this x on this side. So, therefore, x plus 4y. Bring this 8 on the other side. So, it becomes plus 8 and plus 1 becomes 9. So, this becomes the equation of the straight line. That is very simple. Okay. So, that is called double point form of equation of straight line. Okay. Double point form of equation of straight line. Now, let us understand one more thing. See, whenever you draw a straight line, suppose the straight line is like this, okay? Then remember that it will intersect x-axis at some point. So, let us call it A. And it intersects y-axis at some point. Let us call it B. And this is the origin. So, this OA has got a special name and it is called x-intercept. X-intercept. Okay. And this distance from origin to the point of B, that is called y-intercept. Y-intercept. Okay. So, there are 2 intercepts. This length is called x-intercept. This length is called y-intercept. Generally, we denote this x-intercept by A, small a, and this is denoted by small b. Right. Now, remember about intercepts that if the line is parallel to x-axis, then there won't be 2 intercepts. Right. So, if the line is parallel to say y-axis, then there will be only one intercept here, x-intercept, no y-intercept, right? In this case, for example, there is only y-intercept, but there is no x-intercept. So, if one of the intercept is missing, that means the line is either parallel to x-axis or parallel to y-axis. But if there are both intercepts, that means the line is neither parallel to x-axis nor parallel to y-axis. Both intercepts can also be 0 if the line is passing through origin itself. If the line is passing through origin, then there is no x-intercept, there is no y-intercept. Okay. So, these are the intercepts. Okay. So, now equation of a line, if I want to find out equation of a line, provided I know 2 intercepts of the line, then it is called double intercept form. Double intercept. form. Okay. Now, that means I want to find out equation of this straight line, right? It is making an angle, is making an intercept of x-axis A and y-axis B, right? So, let a straight line make A as x-intercept and B as y-intercept, right? Then what are the coordinates of A? I know coordinates of A. A is a point on lying on what? On x-axis. So its y-coordinate is automatically 0 and x-coordinate I know is A. Similarly, the point B has x-coordinate 0 and y-coordinate B. But what is this? This is equivalent to giving you 2 points on the line. So you already know 2 points on the line. And just now we found out the double point form of equation of straight line. What is the double point form of straight line? I'll write it again. So it is y minus y1 upon y2 minus y1 is equal to x minus x1 upon x2 minus x1. Correct? So let us call this as x1 y1. Let us call this as x2 y2. Correct? And just put it in this formula, right? So y minus y1. What is y1? 0. y1 is 0. Divided by y2. What is y2? y2 is b. Minus what? y1, right? But that is again what? 0. So this is equal to x minus x1. What is x1? A. Correct? Divided by x2 minus x1, right? So what is x2? x2 is 0 minus x1. x1 is a. Correct? So this is the equation. Now if I simplify this a little bit, what will it look like? Let us see. So this will be y upon b. This will be y upon b is equal to x minus a upon a. Correct? Sorry, upon minus a. Okay, fine. So that means if I cross multiply, I'll get minus ay is equal to bx minus ab. Correct? Minus ay is equal to bx minus ab. Therefore, what do I get? I get bx plus ay is equal to AB. Correct? This BX is kept on this side, this AY is brought on this side, and this minus AB goes on that side. This is how we get. But divide throughout by AB. So if I divide by AB here, right? If I divide this term also by AB and this term also by AB, what will be left? Here B goes, here A goes, and here both of them will cancel, right? So therefore the equation becomes what? X upon A plus y upon b is equal to 1. Correct? So x upon a plus y upon b is a double intercept form. Correct? Now this is the third form that we have seen. Okay? So let us summarize what we have done today. To summarize, we started with the concept of slope. Slope is defined as y2 minus y1 upon x2 minus x1 denoted by m. Then we realize that there is something called inclination and tan theta is nothing but what? Slope. Then we have learned a slope point form of equation of straight line. Y minus y1 is equal to m into x minus x1. Then we have learned 2-point form of equation of straight line. Y minus y1 upon y2 minus y1 is equal to x minus x1 upon x2 minus x1. And then we have learned a double intercept form, that is x upon a, y upon b is equal to 1. So this is the summary of today's lecture. Okay. So memorize these formulas and understand the relationship between them. Thank you very much.